Alright guys, today's goal, the learner will understand how to use normal distribution. Okay. You've studied probability distributions. One type of probability distribution is a normal distribution. A normal distribution is modeled by a bell-shaped curve. This is the bell-shaped curve right here. It is called a normal curve that is symmetric about the mean. The mean is the middle. It's the average that goes right in the middle, okay, of the bell. A normal distribution with mean x and standard deviation has the following properties. The total area under the related normal curve is 1. So the total area under this is 1, or if you think about that, 100%. About 68% of the area lies within one standard deviation of the mean. Within one, that means from the mean you go positive 1, negative 1. About 95% of the area lies within 2. So 2 to 2. So when it says within 2, you're looking at that whole area. Okay? About 99.7% of the areas lie within 3 standard deviations of the mean. Okay? So let's look at some problems here. It says a normal distribution has a mean x and a standard deviation. Find the indicated probability for a randomly selected x value from the distribution. So let's look. We want the probability that we are going to be less than the mean. Well, if you just go less than the mean, that's right here, that would be 50%. Or 0.5. The probability you're greater than the mean, well, you're greater than the mean, well, 50% or 0.5, because it's half. The bell, standard normal curve, bell cuts it in half. Okay, let's look at this next one. They want it to be between the mean and 2 standard deviations. So if you look, we want to be from here to here. So we have 34 plus 13.5, which is 37.5, or 47.5. So the probability is 0.475. Okay, so let's look at the next one. This one is asking, what is the probability that x is less than or equal to 3 standard deviations away from the mean, negative 3 standard deviations away from the mean? So we are only looking at this little piece. Now, how did they get that 0.15%? Okay, well, if there's 99.97% here, that means 1 minus 0.997 is 0.003. But that means for this area and this area. So since it's a normal curve, what we have to do, though, cut that in half. So you get 0.0015, which is 0.15%. Okay? So there we go. So, health. The blood cholesterol readings for a group of women are normally distributed with a mean of 72 and a standard deviation of 14. Okay, so if we think about this, the mean is 172. If I add 1 standard deviation, I'm doing 172 plus 14. 186. If I had 2 standard deviations, add another 14, 200. 3 standard deviations, 214. Subtract the 14. 158. Subtract another 14. 144. Another 14. 130. Okay? So here's like the middle of the bell. So there's our bell curve. And it says between 172 and 200. So if we think about this here, we're looking at the probability we're in that area. But that covers 2 standard deviations. So remember, we know this was 34%. And this one was 13.5%. So what's the probability? It says what percent of the women have readings between those two? Add those two together. What percent does? 47.5%. So see how we can use this normal curve to figure out some percentages? Okay. Alright, so standard normal distribution. The standard normal distribution is the normal distribution with mean 0 and a standard deviation of 1. So that means the average is 0 and the standard deviation of 1. Okay? The formula below can be used to transform x values from a normal distribution with mean of x bar and the standard deviation of sigma into z values having a standard normal distribution. Okay? So if you look at this table here, see how it says z equals 1? That means it's one standard deviation. Doesn't matter what that standard deviation equals, but it's one standard deviation away from the mean. When z is 2, that means 2 standard deviations. If it's negative 2, it means 2 below. Okay? So let's look at this example down here. It says this is our z table. We'll just have to use that after we calculate our z score. Okay? Scientists conducted aerial surveys of a seal sanctuary and recorded the number of X seals they observed during each survey. The number of seals observed were normally distributed, that means we can use this, with a mean of 73, that means X bar is 73, and a standard deviation of 14.1. Sigma is 14.1. Find the probability that at most 50 seals were observed during the survey. So at most 50. So that means 50 or less. Okay, so that's what our curve is. Because this curve always tells you the percent below. Okay? Not the percent above, but the percent below. Okay? So what do we do for this? You say 73 minus, what number are we looking for? 50, divided by the standard deviation, 14.1. That gives us our z-score. Okay? So 73 minus 50 divided by 14.1 equals 1.6. Why did I do tenths? Because that's what our table gives us at. So I look at 1.6. Oh, hold on. I knew something was up. Let's take a look here. It shouldn't be 73 minus 50. It should be 53 minus 70. It's x minus the x bar, so it would be negative 1.6. So you go to negative 1, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. So the probability of that happening 0.0548. Okay? So you guys press pause, try to find the answer to the next one here. Try to find the answer to this question here. So hopefully you press pause. So we go Z equals 90 minus 70 over 14.1. So 90 minus 70 over 14.1, you get 1.4. So if I look at 1.4, I have 1.0, 1.1, 1.2, 1.3, 1.4. So the probability equaled 0.9192. So that's how we use the z-score. Okay? That only works when it's normally distributed. This word right here, normal distribution, that's key. Okay? Explain why it makes sense that the probability that z is less than or equal to 0 is 50%. Okay, so take a look at the z chart that we had on the previous problem that you copied down. Try to explain that and bring your answer in. See you guys tomorrow.